groundwater production. How do we get the water out? How do we protect our source? How do we describe that water quality? What are the components of wells? How do we disinfect them? How do we calculate volumes of a well if we needed to disinfect? How do we, because we can go in there and we can figure out our water level, we can figure out the diameter of our pipe, we can figure out the depth of our well casing, we can figure out how much, if we need to disinfect it to a certain level, 50 milligrams per liter, something like that. We need to know how to do those calculations. They're very beneficial. We're going to look at the different types of aquifers, and then some of the things that we do with groundwater treatment. Fortunately, with both groundwaters, we really don't have a lot of treatment necessary. Sometimes you're looking to try to make the water a little more stable. You might have some dissolved gases in there that you have to deal with, some dissolved minerals and things like that. But the good thing about groundwater, most of the times it's pumped it, disinfected, and sended. Pretty straightforward. When we're looking at the hydrologic cycle, how do we actually get groundwater? How do we get water back up into our groundwater sources? Well, we have evaporation coming off of our oceans, our large lakes. The atmosphere is one of our biggest water storage in the world. We talk about the polar ice caps and things like that. The atmosphere has so much water available in it at any point in time. And then, of course, we've got to get it out of the air, so precipitation, rain, snow, sleet, even fog as a form of precipitation. And then we're going to have it recharge back into our groundwater systems. All right? We're also going to have surface runoff, but we have two different types of wells, of aquifers that we're looking at. We have shallow water table aquifer that's unconfined, so the actual water level moves up and down as you're pumping out of it. Most of those are alluvial in nature. What is alluvial aquifers? It's aquifers that are close to rivers in flood zones. As it floods, it pushes out a lot of silts and rocks and stuff like that, and over time it builds up, and that's a great storage opportunity for water. We go back and even look at biblical times. They knew that it was a lot safer to dig a well somewhat close to a river than it was to get the water out of the river. So even then they recognized the potential of pathogens and so on in the surface water versus the benefits of natural filtration through the groundwater. And then you have your confined aquifers, which has an impermeable layer on top of it. It'll typically have a recharge zone, and then it's actually under pressure. And so the water table doesn't fluctuate, but as you pull out of it, the pressure fluctuates in there. And there's actually some expansion and contraction of the materials that are in there. And then one of the big things that we were talking about earlier is our saline groundwater. There's a lot of brackish water aquifers. In Texas, they're working on maps right now for them. That's the next wave of water, that's the next water source. It's a lot less in total dissolved solids than if you were pulling it off of Mexico. So it's a lot easier to treat, about 10 times less, 10 to 100 times less depending on your source. So Texas Water Development Board is building maps in the state of Texas. The city of San Antonio is already drilling for brackish water wells. We're putting in a 10 MTD RO system, and they're going to figure out how that works. And then the good thing about ROs is they're modular. You can just easily expand. You can bring in another setup, and now you're at 20 and 30 and so on. So brackish is, especially in areas that are dealing with a lot of drought conditions and all, Texas, Arizona, New Mexico, a lot of those places, especially West Texas. West Texas is actually looking at, they've already got it going. They're doing toilet to town. They're coming off of their wastewater treatment facilities, taking that discharge, running it through a RO process, splitting it back in with their raw, and the raw is untreated, and then it's going back through a treatment process for each of the small cities. So they just are in that situation. Like in any rainfall, there were reservoirs that they built back in the 50s that used to be full, are now down at 8 and 10% capacity or something mud. And they've actually got floating intakes now to try to get out where the water is to give them some water while they're building these. Their groundwater sources are horrible, really high in chlorides. I mean, it's talk about the Dead Sea. That's what they're pumping out of, basically. So anyway, we start looking at our different aquifers. that's some of the dynamics that we're looking at. And saline and RO is really coming along in a lot of ways. A lot of research coming out of universities, especially like out in California, where they're making membranes that water passes through real easily, the hydrophilic pores in the membranes, and so the water doesn't take nearly as much energy. We talk about a lot of pressure differentials in our RO systems. Pressure is energy. Energy is money. So if we can have the water pass through a lot easier, then we don't have to have as much pressure. It's a cheaper process. So a lot of those things are changing with technologies. I was looking at this a little bit earlier, and it's interesting how much surface water y'all use, because if you look, the state of Tennessee, even though it's a small picture, y'all have two major aquifers running right through your state. Most of your state is, has some sort of very large aquifers. So I don't know what the water quality is, and I don't know how prevalent it is throughout the state. And obviously you have good rivers and so on. Surface water is always more expensive to treat than groundwater. So it's just interesting to see some of those dynamics. And I guess out on the middle and western side, you have more groundwater systems.
Yeah, Western cities on 3 or 4 surface water intakes. They're all like around Tennessee River.
Right. But almost everything out on this side is. What do you think the percentage is? Just a rough guess.
Surface water.
I'd actually say the number of systems is probably pretty equal, groundwater to surface water, but then when you get into capacity,
Volumes,
most of the groundwater systems are smaller systems, and most of our larger systems utilize surface water. So percentage of water use, I'd say probably 80 or 90% is surface.
Well, see, you might have a lot of water there, but you might not be able to get it out easy. The transmissivity of your aquifers and stuff like that, how easy the water flows. Again, we're in a lot of ways people harp on the water in San Antonio because it's hard. It's a lot of alkalinity in it, hardness over 200, 210. I mean, it's a rock sometimes. Yes, sir.
I got a question for the, I don't know your name. I'm pardon me? Keevan. I've talked to you, but
Yeah.
Our lake levels in Watauga Lake have, they turned it into a recreation lake, and years ago it just dropped down. Now they don't drop it down at all. Are they using that as like a flushing? Is it?
What's happened this year, we've just had record
I
rainfall.
understand even in the past, it seems like they're keeping us up a lot more. And,
A few years ago, TVA came back with a new operating guide for all the reservoirs, which typically causes them to stay at full pool longer because of the recreation. Things like that.
Well, it's got worse, and I mean, in my mind, that they're holding it to flush river systems so that you can draw it out.
They hold it to a certain extent, but you can go to their website and it shows a graph that they try hard to keep it in that operating guide level. They've changed them around because of recreation, water use, things like that. Because for one thing, they try to help keep float barges down Kentucky Lake when they need it. But one of the things that they hold too much, they're going to flood Chattanooga. So that's kind of a bottleneck in the system. Whereas they had a lot of development in Chattanooga down along the riverfront. If they let too much water loose up here, or don't have enough capacity, if we get one of these big 5-inch 24-hour rains, they're going to flood Chattanooga if they do hold too much water up here. So it's just a balancing act for them.
I was just wondering because I'm dealing with docks all the time, and it's.
Oh yeah. This year it has to have been a nightmare.
But see, like Boone Lake, they didn't bring it up at all. Even in 11 inches of rain we had, they stayed the same.
Boone doesn't have nearly as much storage capacity as with all that.
But they didn't move it at all.
Then we also have. They generate a lot. They also have a pretty good lobby.
What?
On Boone Lake.
Oh, Boone Lake, not to be jumping around.
Yeah. They've talked to TVA a lot, that Boone Lake Association.
So the squeaker wheel gets. I
didn't say that.
I just thought
they have a pretty
because
strong association.
The quality of Watauga's water
Yeah.
is something that you want to maintain to flush down so that the folks downriver can have a better quality of water coming through.
All that stuff went into their operating guide, but, you know, there's a lot of different competing interests
Right.
who have a seat at the table on what they do. And that balancing guide is just that,
Politics.
they took everybody's input, came up with a working level on how they're gonna run everything.
There's a tremendous amount of things that you have to consider when you're, looking at how long you hold water in a specific lake, what's the influences in your watershed. Because if you have a really nice lake, and now you have a lot of nutrients and all coming off of agricultural, now you're gonna have eutrophication, you're gonna wind up with a lot of algal growth in there and stuff like that. How much water is actually being recharged, because lakes are a major source of recharge for aquifers, depending on the type of aquifer. And that's why some lakes might lose their level faster. There's discharge issues and all that, but politics is always a part of it. Just it's inevitable, especially when you have the state, agencies or something involved, or even federal.
This is a federal issue.
There is always interest. But we have issues in San Antonio because we're on a really, really large karst aquifer, one of the largest in the world. And karst is limestone. And so they found some endangered species, some little blind salamanders and different things up in one of our springs areas, up a little bit to the northeast of San Antonio. So that really impacts the pumping rates. Whenever you have Endangered Species Act, it's huge, big deal. So now we are really and there's a lot of growth in the area, a lot of demand, but federal government's coming in and saying, y'all either work this out among yourselves, or we're gonna come in and help you. So everybody's scrambling to work among themselves to try to get cooperating agreements and all, in order to look at historic pumping rights and rates and all. So there's a lot of dynamics.
There's just a lot of competing interests. They finally just come up with it's going to be pretty much the best way to at least partially satisfy everybody.
Yeah.
And still fulfill their function. TVA, one of their main functions is flood control.
Because they're flooding you.
Because right now,
Yeah.
we had record rainfalls recently. Douglas was 25 feet. It was at summer pool just a few weeks ago. I mean, it was 25 to 30 feet higher than it should have been this time of year.
Yeah, we were at summer twice this year.
Y'all were over summer. When I was doing the survey, I kept driving through and
I looked at nice little
fishing
island,
pier was
big
underwater.
bridge is gone.
Yeah.
And then you start asking, like if you're having flooding issues up where you're at, so then they look and they say, well, how many people are impacted here versus how many people are impacted downstream, and there's just a lot of that.
Because Chattanooga has been one of the reasons they've had to hold so much up here. Because if they turned it loose to keep our lake levels where they should be, Chattanooga's flooded.
So you even need to say it, but the people that live on Boone Lake, if they wanna ride their jet ski at Christmas time, they want the water just right.
Yeah, you probably have to warm it for them.
Yeah, but that was the thing,
Yeah, I didn't say that.
They could have,
I did.
they could have took so much water off of us if they put it in Boone Lake. Because it was down.
I agree.
So it's interesting. But we look at it, aquifers, and back on the aquifers, like in San Antonio, we're on a major karst, and so we have wells that, it's a 20 MGD well, 20 million gallons per day that it can produce, and there's almost no drawdown on the well. The aquifer is that prolific. You've got almost no drawdown, and we'll start talking about that in a minute or two. But so then you get into other areas, and you've got to put your well so deep, because even though you've got a big aquifer, you can't get the water to the well, and that's why a lot of times you'll go to another source, because it's easier to pull it off of the lake than it is to have that many wells out there to put them so deep, because now it's more energy cost, stuff like that. So how deep is your well? You have an idea?
It's 300, but because I've had geologists come out, and there's a cave that goes down 350 feet, and ASU dropped a boat down in there, and they went for 4 days. They circled around and tried to find walls in this cave, and they couldn't. It was all water, and it supposedly runs right under our property, and that's where we're getting the good water.
Wow, that's awesome.
Yeah.
That's interesting. How deep are y'all's wells? 36. Yeah, from 300 foot. Don't have any problem with getting water? Pretty good water.
Just use hydrological.
Submersibles. Okay. This is what we were talking about earlier, when we look at a combined aquifer versus a shallow water table aquifer. Again, in a water table, the actual level, if you went out and measured, if you had a well casing you wanted to stick a transducer down into, you can actually see the water levels change. In an artesian aquifer, it's under pressure, and they'll actually blow up out of the ground depending on where you drill it. And there's a picture of one that was right by the San Antonio River back in the late 1800s that they drilled. It was like a 24-inch casing, and they have a derrick up above it, and you can tell it's way off the ground, and the water blew up above that. For several days it took them before they could get it sealed off. It was just that much pressure in the system to blow, 24-inch casing, 20, 30 feet in the air. So that's substantial pressure that's associated with it. Now with all the demand, we don't have that. We have a lot of springs up at the head of the San Antonio River that at certain times of year now they go dry because there's so much demand on the aquifer, where you have information from years ago where the Native Americans and all, there was a huge amount of water coming out of there because you had such a huge recharge zone. So anyway, hydraulics is really interesting. We could have a whole class on hydraulics, but it really affects how your pumps are going to run, how far you have to pull your water and stuff like that. So we look at our springs. We can have natural springs float up out of the ground. Then we have our water table aquifers, and then we have our artesians. Artesians are under pressure. So we're going to get it through percolation, especially on our shallow water aquifers. It's going to actually go down through the soil. Big one is coming out of, we just talked about lakes and all, rivers. So bank storage is a big component of our actual capacity of a river. And that's why alluvial aquifers close to rivers can be very beneficial. It can also be under the influence. It can be a gooey, a groundwater under the influence of surface water. So we have to be careful in our proximity. And then overpumping can be a real big issue depending on your recharge rates. The Ogallala aquifer up in North Texas, up in Oklahoma, has been used so much over so many years they're dewatering it. And they're losing a major resource. People keep dropping their wells deeper and deeper and still pumping as hard as they can. And you don't have the recharge rates. They're losing that source. And water is a very precious resource for us, and so we need to manage it well. So that's a big issue in a lot of parts of the country. When we're looking at our wells, how did we build it? How is it constructed? Back in the old days, talk about biblical times, out there shoveling, shoveling bucket. Then we get into where we can actually do it with an auger, depending on how deep it is. Not real practical unless it's a very shallow well. Driven, haven't really seen any driven points. That's old school, just hammer it down through whatever material is. And then of course the most common nowadays, we've got the drill truck's gonna come out and they're gonna drill for us and put in nice casing and all of that. Looking at our parts of a well, down at the bottom of our well, we need to have some sort of a screen. How do we know what screen size we have? Well, we're going to base that on the materials in the aquifers. If you have real large particle materials, then you don't need a real fine screen. But if you've got a lot of sands and so on, you need a nice screen. One of the things that they do to help with your well production is they'll take a reaming device after they drill down. They'll put it down in there, and as it spins, it actually has blades that open up. It'll over-ream the well for you down there, whatever your screening area is going to be. And then they'll put in a gravel pack. And the gravel pack is to help separate the natural aquifer materials from your well screen. And so as you're pulling, you're going to pull a nice even flow of water in rather than sucking up materials next to your screen and then you got to purge it and things like that. We do need to have, the casing has to be sealed well. When we talk about wellhead protection, we got to not only protect on the surface of the ground, but we also need to make sure that our casing is intact, is sealed properly, things like that. And of course, in some areas you can have a couple 100 foot of screening, depending on how big your aquifer is, how big your pumps are, how much money you have.
Around here, they don't use screens, gravel pipes. We use open borehole.
Really?
It's a solid rock.
Yeah.
Yeah, we pretty much don't have alluvial wells in East Tennessee. Pretty much everything's either coming from caves or fractures or.
And see, that might be part of the issue, depending on your substructure, because we have huge open caverns in San Antonio on our system, and so we can flow tremendous. The transit time from do a dye test from the north to the south could be a couple of days, where in some systems it could be 1,000 years, you know, depending on how fractured it is and how easy the flow is. So I guess that's might be one of the reasons you might have a lot of water, but it's not easily accessible. You know, unless you hit, like say, if you hit the right one and you got a giant cavern underneath, you got a 5 million storage tank, you know, naturally based storage tank underground. I know in Florida they have a lot of issues with cave-ins, subsidence and all, because they are dewatering. They have a shallow overlay over their aquifers. They're reducing that pressure, building everything on top. Now you got giant sinkholes and stuff. We don't really have that problem because our overlay is so thick. I would imagine here too, I don't have any issues with
We
it.
have sinkholes.
Do you?
Oh, yes.
We don't have in the scale that they have in Florida. Ours tend to be smaller and tend to be the ones that develop a little bit slower over time.
Okay.
More of
No.
a dissolution than a collapse type,
Okay.
but we do have them quite frequently, actually.
Interesting. But we have in our recharge zone, we have a lot of the sinkholes that are basically surface access into your aquifer, so you gotta really be careful. They're doing a lot of protection up in the recharge zone of what are you building up there. Underground storage tanks is a huge issue. Impervious surfaces, concrete, asphalt, things like that. They had a real big issue with the PGA gonna build a couple of golf courses out there because they were worried about the pesticides and all. And they did a study, and you have professionals out on the golf courses that they only want to use exactly what they need because it costs them money. But then you have the homeowners that are out there spraying any and everything they can get with, you know, fire hose size volumes, and it's all running off. So where's your real source of contamination? But they just see an easy target a lot of times. So that's interesting. At least you don't have where the homes used to be. There's a giant home now. That's
Well,
nice.
actually,
Every once in a while.
so recently we had a swimming pool disappear in the backyard of the house, and then about 50 feet out the corner of the school.
Wow.
150 feet deep.
How deep are those wells where you were?
We're looking at about 300 to 400 feet. So they're not super deep. They're not 1,000 foot. Now the brackish are pushing like 1,500 to 1,800 feet. We're getting into brackish. That was real interesting too with the brackish because it was down south and some of the smaller farming communities, and it doesn't matter what kind of water it is. I don't care if I can't use the water, you still can't have it. Mentality they're really in Texas, whiskey's for drinking and water's for fighting. So that's really the mentality of a lot of that.
We had Atlanta trying to
Yeah.
stick a straw in Tennessee recently.
Yep. It's all about availability and diversification, and it's all about resources. I'm a big states' rights guy, so let the states kind of maneuver and fight around and see.
Do you ever think that water's gonna be a commodity and like the?
Oh, it is.
Well, I mean,
already.
it's like gasoline, it's like $90 a barrel. So is there a price for water right now?
I would say it's more regional as far as people look at the prices, but there's already a lot of speculation going on. There was stuff out in the western port of outside of San Antonio and the surrounding communities, because the Edwards Aquifer covers a number of counties. So there's people out there looking at buying water rights to different properties in order to try to sell it. So they're speculating, and it's a big business right now, and it's happening in a lot of places.
They about for agriculture, these wells, they charge the tanks on the water, amount of water coming out of those wells.
On the ag side, they're trying to regulate them now. Trying to ask them to put meters on it and stuff like that on their pivot irrigations and all. They're trying. There's a lot of fighting about that. There's a lot of fighting. But what they do is in Texas, I don't remember if it's 2 or 3 acre foot per acre that you have the water rights to. And so if you've got 1,000 acres now, you can 2,000 to 3,000 acre feet that you're able to sell off to somebody.
Well, in California, LA, one about thousands and thousands of acres of irrigated farmland with water.
Yes, sir.
So it'd be idle now. And the food, I guess, would come wherever.
Well, we've talked about in looking at the Mississippi River, what kind of issues they're having with their barge traffic because the water levels are so low. So if you look at you know, y'all are getting a lot of rainfall, but there's other places that aren't. And you look at the amount of demand on the river. What's the watershed feeding, as opposed to historically? What's the usage right now for the, coming off the river? It's a tremendous amount. I went through Vicksburg not too long ago, last summer. It was amazing how much sandbars, you know, I mean, the river looked like. You could step across it. I remember years ago we went through there and it was bank to bank.
Another consideration is that people have discharge permits, it's sort of based on a certain flow. So that flows down 80%, so you're going to be more concentrated on the pond, which will make it harder on the water system. Use surface water.
Yep. Well, we were talking about that yesterday when we were going through the surface water treatment rule, and you start looking at your backwash filter rule. What can you discharge? What can you recycle? You're concentrating it, so you don't want to blend it right back up at the front of your plant. But if you're going to discharge it, now you got to go in through a TEPDES. You know, got to have a permit to discharge. So I mean, there's a lot of dynamics that go into all that. It can make your head hurt after a while if you get into it too far. But really interesting water stuff. A lot going on, and a lot more people now are educated on water resources, conservation. Even as an industry, we're learning a lot more as operators and managers and stuff. So the different parts, we talked about the well screen, the gravel packs. Interesting that y'all are just punching a hole, dropping a well down, dropping a pump down in there. A lot of the stuff that we do, if it's up on the car stuff, they're just punching the holes. We were doing a lot of this down south where we had a lot of real fine sands and all. So you got to have a real fine mesh screens on it, and then you have to really make a big gravel pack. And then you have to be careful how you run your pumps, or else you're going to really work that in there. You don't want to have a lot of starts and stops. You want to be able to run them for a longer time, so you minimize your surging.
I was going to say we use a lot of sand packs, pre-packed sand packs. It's all we need down there.
Yeah. Yeah, so you've got to be able to put something in there to keep that from infiltrating in. What are we going to do about sanitation? Real big deal with abandoned wells, old wells sitting out in the middle of a pasture somewhere nobody knows about or forgot about. Now you've got surface contamination getting in there real easy. Once you have your aquifer contaminated, very difficult to clean it up. There's some real big projects, even one in San Antonio, military base. Their disposal method of especially a lot of their organic solvents and all, which is dig a big pit, put in the pit, hey, it disappears. Great. That was a shallow water aquifer in there. And so now they're pumping it out on their downstream gradient, treating it, and pumping it back in upstream and helping the gradient head move a little bit faster.
That's happening a lot.
Huh?
That happens a lot in Tennessee, Milan, West Tennessee.
Yep.
Explosives, contamination, have 3 pumping treating systems. They're pumping it out of the ground, running through carbon, and you inject it before they start to the surface stream.
Yep. And what is that costing? That's a lot of money.
One plant is $15 million.
And whose money? Mine and yours and yours and yours and yours. So, yeah. So there's a lot of things that we're dealing with because of old techniques and stuff that weren't that great. So if you have a program to go out as a regulatory agency to go out and identify abandoned wells to help seal them, that's an important part of your source water protection program. It's important to have fences and all. We talked the last couple of days about in Texas, if you have a well, you have a tank or whatever else, you got to have a fence around it. You got to have 25 foot on every side. Got to be 6 foot cyclone with a 3-strand barbed wire at 45. Got to be locked. Got to have signs. All of that stuff. Here, it just kind of depends on the facility. From my understanding, vandalism is a impetus to go in and put in fencing and all, but not everything needs to be fenced. Is that correct? So it's just every state kind of handles it a little bit. Huh?
Pre-compliance, things like that.
Sure, yeah. But I mean, any pumping station, primary, secondary,
We asked that the well needs to
wellheads.
be locked, you know, that's something they can lock.
Yeah. So it just depends on the state, how they handle it. But signage is really important too. To have up information about who the utility is, what their contact number is. Homeland security is a real big issue. So if you have something up there about authorized personnel only or whatever else, the penalties for, used to the kids who go out there and spray paint on there and this, just a pain to go out and paint it. Now you're potentially tampering with a water source. Homeland Security takes that very, very serious. There's federal crimes associated with these things now. Used to it as a misdemeanor, slap on the wrist and call your parents. Not anymore. So as an industry, we have to make sure that we really look at how do we protect our sources. You've got to have a sealing block. Start looking at some of the components of it. Need to know how much we're sending. You have a meter on you. You got to know how much you're pulling out. Need to have proper venting for your casing and all. And then you got to be able to have a way to test it. It's best to test it close to your wellhead. That way you don't have to worry about any other potential contaminants. You know what's coming out of your well. Then you got to test periodically. One of the big things about sanitary control easement, you don't want your cattle walking up next to your wellhead. You don't want a septic system 15 feet away from your wellhead. So you need to make sure you know what's around and what's potentially impacting. So just a quick diagram. We have our pump column, we have our surface casing, need to have it properly cemented in. We need to have a sealing block so we don't have contaminants filtering right down from the surface. We've got to be able to vent our well because as we're running it, we're having pressures changing in there, so we're going to be able to vent. This is showing a vertical shaft turbine here. The motor is up on top, and you have a shaft that runs all the way down. Normally those are the big wells. If you run in small wells, it's mostly submersibles. Those are the most common. So you got to have relief. You need to have a check valve so you're not pulling a siphon and then flowing back in. So you got to have air relief and stuff. And you got to have some way to meter what you're pushing. Talking about our distances from our wellhead, you want everything at least 50 feet away, and then as you start looking at your septic systems, they need to be further out, and wastewater treatment facilities. We get into distribution, we're going to talk about how far do we want our lines apart from each other, our water mains and our sewer mains and stuff like that. So we do need to make sure that we segregate these things to minimize the potential contamination. We talked a little bit about disinfection. After we have a new well drilled, or if you've had some construction done to it, some work done, or you're having a water quality issue, sometimes you need to go back and disinfect it. But some of the wells there in the San Antonio area have to deal with the iron bacteria. So it grows a real nasty slime in there. You get some really, really funky water quality. So periodically you got to go in there and dose your wells.
Luckily, that's not something we represent with
And it just
West
depends.
Tennessee to do.
Yeah, aren't you glad I did it east?
Yes, we are.
But, no, those are just some of the things that you have to potentially deal with. So then you need to be able to go in and calculate the volume of the well casings so you can actually dose it properly. And we need to let it sit for at least 6 hours at 50 milligrams per liter. Then you got to take back teas and 3 consecutives. And then if you have a new well that's going into service, you're really supposed to over pump it to help develop the well, pump it for 36 hours, and then that's when you want to start pulling your analyses so you can kind of figure out what the water quality issues are. And good thing with groundwater, once you figure that out, it's normally real stable. I like groundwater a lot. It's real simple in many ways. So when we're looking at our well casing, whatever it is, when it's sitting still, not running, that's going to be our static level. And then when our well is running, we're going to have our pumping level. I don't know if y'all have a way to measure, but sometimes you'll have a little casing there that you can you can even use something as simple as a little plumb bob on string, run it down and measure it, and then test it when it's static, test it when it's running.
So what happens if our water overflow the casing?
It comes up out of
We
the top.
have like 250 feet deep,
Uh-huh.
but if we will not pump, the water overflow the casing.
Oh, then you're probably in an artesian well. You're under pressure. That's why it's flowing up out of there for you.
So we just keep on pumping out on
Do you have a check valve on your
Yeah, we
discharge
have.
side of your pump? So-
No, we're not using the reel right now,
Uh-huh.
but it keep on overflowing.
So when it's not running, it's still flowing?
Yeah.
What you would need to do is them, and you can help, but you need to look at, there should be drilling records on it, and you can look at the aquifer type, and if it's an artesian aquifer, then you're probably flowing. But you gotta look at your hydraulic rate. Are you at the bottom of a hill, you at the top of a hill? Where are you at?
So see that?
It's pretty flat, but what do you have around you? Is there any hills around you, or?
Yeah.
See, cause it.
Not that high.
Yeah,
But
but it,
what you can do is just, they can go in and basically weld the pitless adapter, put a separate pipe
Mhm,
out.
that's what we do.
Okay, start saying, we had some artesian wells.
Yeah.
And so, basically, it's just, you're not running, you have to put it someplace, so you don't want it all in your treatment building, so.
yeah. That's what part of the process of, I mean, it's good to show an artesian, 'cause that means you're not using a lot of electricity to get the water out of the ground, because it's up there real close. And is it at certain times of the year that it flows like that, or is it constant?
It's constant.
It's interesting, because normally artesians, again, you have to go and look at your hydraulics and all to see where your aquifer actually flows to. But if you're on the low end of the aquifer, you're gonna have a lot of hydraulic pressure, and sometimes it'll fluctuate throughout the year. You know, dry periods, you're not getting much rain, then it shouldn't flow, and when you have a lot of rain, then it should flow a lot.
Most of ours, at least in this area, we have such high variance that if it's artesian,
It's always flowing. See, and that's some of
If
their.
they're not pumping it down, it's going to overflow. There's aren't that, there's a few.
Yeah. Well, at least you know you got a lot of water there available to you.
Yeah.
That's a good thing. So yeah, then you just need to be able to pipe it off somewhere. Try to find a beneficial use for it. You know, some sort of an irrigation system or, you know, whatever, something to be able to utilize it. Okay. So then when we're running, we're at our pumping level. So your static level is up here somewhere. Above gradient. And it's actually true. I mean, it'll rise up a certain amount above the ground. So that's where your pressure, that's where your static level is. And then we look at the difference when we're running, between when we're running and not running, and that's our drawdown level. So how much is a drawdown? And if you have a real strong artesian, you're probably gonna have very, very minimal drawdown. You know, maybe if you're running constantly for a long time, you might, but I would imagine that, you know, you probably don't even need a 5-horse to be able to get water out if it's that
This one we
close.
just use like 1.5 horsepower.
Uh-huh. Yeah, because
So
that's,
50 get until
Yeah.
250.
yeah. You see, but your pump might be that far, but the water in your casing is up really
It's
close to
all
the
the way
surface.
up.
Yeah, so it takes almost nothing to push it out, so that's a blessing.
Yeah.
All right, here's a vertical shaft, but the submersible is the same, it's just got your motor on the bottom, but depending on how high you have to push the water and what kind of volume you're looking at, you're gonna have to have a certain number of impellers, call them bowls. We were running like 6 bowls off of a vertical shaft, and we were pushing about 2.2 MGD off of each one, of 18-inch casing, so it's pretty good size pump. We did a lot of vertical shafts. West Texas is having a big problem with the oil and gas stuff, so they were running verticals for a long time. Now, because they can't keep mechanics on site, electricians employed, they're switching over to submersible. So every time they have something go down, they're pulling it out, dropping it in a submersible, and that way, if they have an issue, they just gotta have a drill company go out there, pull it out, put a new one in, put it back in the ground, and back in business, because they can't keep people to keep their equipment. It is interesting, yeah. I mean, you're changing your whole operational dynamics because of your employment opportunities. So, you know. So we have our submersible, which is down below, it's water cooled. Vertical shaft is gonna be air cooled and have oil in it. And then we look at our series of pumps. Again, remember, anytime we have anything that's oil, lubed or something like that, it has to be NSF approved. Real important. So how do we, if we do have issues, if we have gases especially in our water, the easy way to get rid of them is aeration. We might have to do some corrosion control. Typically, groundwater is going to be more stable than surface water. We're going to have more minerals and stuff in it, so it's a better water quality. And then sometimes they actually need to soften it. We don't. We did just the opposite. And then you get into your special processes, which is basically a surface water treatment if you're going to try to do coagulation and all. Or you can use RO if it's a real poor water quality. Talked about GUIs, groundwater under the influence. So if you have a shallow well, and every time it rains, you can tell your water quality's changing, you're under the influence, pH is changing, your turbidity's changing, things like that. Especially the real shallow wells, real close to water sources, can fall under the GUI. So that's something to think about. Here, if it's in a karst, probably not, high probability not. But if you are, then you have to start looking at surface water treatment rule, and you got to start looking at your pathogens like Giardia and crypto. And then ultimately, you need to evaluate what your surface water quality is in that area if you're under the influence. And that is groundwater production. Any questions? Any comments? Appreciate the info.